This session is the Intro to Deluge session. I'm going to walk us through some kind of key concepts. So the first thing that we want to talk about Deluge is this concept called variables. Variables are essentially a container in coding, all right? It's a way for you to store a value, all right? So we have this kind of question here. We have an empty glass. What's in each glass? And we got pink lemonade, root beer, and whole milk. We can break this down a little bit. The blue text is as you know them. In orange, it's the deluge. So these are just a separating of terms. So the glass itself is actually a nice little illustration of what a variable is. It's a container, okay? And that is going to allow us to hold or store some value. So examples of value in this situation would be lemonade or root beer or whole milk. These are actual values in this kind of situation. And so then when we are going to declare the variable or name the variable, and declaring or naming the variable is simply to make use of this concept in our code, we'll have to name it something that lets us know what the value would be, right? It helps us kind of understand what would be in that container, right? So for example, we have like a container like a box, right? Well, if this is a box that I need to take every day to lunch with me, so that way I can be fed, I would call that a lunchbox, right? It's a very convenient way for me to understand that this particular box contains my lunch, so when I need to reference it, it's probably more convenient for me, for you, for anybody to remind me or to say lunchbox instead of just box, or instead something like dinner theater or whatever, right? That has nothing to do with a lunchbox, right? So again, when we're declaring a variable, we are assigning a value to a variable. That is what declaring it means, right? So in this particular case, if we look at this illustration here, it's a glass that's full of lemonade, okay? So the value is here in red and in quotes, which is lemonade, and the variable that we're declaring here is a juice glass, okay? So if we are going to now reference this in the future, we would say juice glass, and then of course that lets us bring up our value, which would be lemonade. Now, the thing that's important to remember here when we're talking about coding or we're doing any kind of, scripting or anything is syntax, okay? Just like in any language, you must be precise with the way that you order your code, the characters you're using, and the casing, okay? So here's an example of some crazy syntax in English, right? This is a English sentence that is written in a very, very, very strange way because it's not actually following any rules of syntax here. It's just completely made up gibberish, random thing that I just put together. It's hard to understand this, even if you are a native English speaker, okay? But of course, what is this? It's a pretty common sentence that we see all the time that encapsulates all the letters in the English language. The quick brown fox jumps over the lazy dog, right? That sentence has been formatted into a proper syntax that we can all understand as English speakers. Who could tell what this sentence was by just reading this? That is because you have very good cognitive and problem-solving abilities because your brain works a specific way, right? Computers do not have this luxury. They do not do this. So the point here is that we, have this ability to naturally kind of sort this out and figure it out. We're able to do that. Computers, not so much. In other words, computers will do exactly what you say, okay? And this, of course, means that they will mess up a lot of the time if we're not super specific about what we're doing. So it's important to remember that if we say something incorrectly, like the brown fox jumps quickly, the computer won't be able to figure out exactly what that means, all right? So we always have to be very careful to tell them exactly what we want them to do. And for now, that's probably a good thing, and we'll see, in the future if that changes, if they decide they get their own ideas and they get really upset about, kind of being these slaves for a long time. I mean, that can be a whole other issue, all right? So for now, they do exactly what we say, and that's what we're going to have to stick with, all right? So again, we'll look at some examples, 3 examples of syntax here. So on the left, we have a green check mark. This is going to be a good example. And on the right, we have obviously a whatever I guess you call this, a no sign, I guess, in red. So variable name equals value semicolon, okay? That is the correct way of declaring a variable and including some kind of value within it. It's a way of containing a value within a variable. Now, notice that this is not the case if we say value equals variable name. It doesn't work that way. It doesn't switch over, okay? That's just not something that happens. So in the example, juice glass is our variable, and it contains the value lemonade, right? Well, would we say that lemonade contains a juice glass? No, that would be a very weird recipe of lemonade, right? That would be probably hurt to drink that, right? So it's important to kind of have this fundamental understanding that variable names or declaring variables is always going to come before the value and never the other way around, all right? Two other things to watch for, right? When we're talking about syntax, these are two common things that are going to throw errors constantly if you're not paying attention to these two basic things. First one, these are more tips than anything. Watch for underscores, okay? You're going to probably use underscores when you're declaring variables or when you're writing code, so it's important that you watch for this because these two things, juice underscore glass and juice space glass, are not the same thing. This one on the left, the computer understands. On the right, the computer does not understand. Okay? So these two things are not equivalent. So when you're writing your code, make sure that you're paying attention to underscores that you're using. If you decide to use an underscore, make sure you know that or remember that you're going to have to use it again in the future. Okay? Similarly, you should watch for semicolons. This is probably like the number one error that causes code not to work, is just forgetting a semicolon. Okay? So on the left again, we have juice glass equals, quote, lemonade, semicolon, and on the opposite side, we'll have the same thing, but we're missing the semicolon. It is a way of telling the computer, okay, this is a complete command. Stop here. Take this. It's kind of the equivalent of a period, right? It allows the computer to understand that this is a complete command, follow the command, right? So for example, if I said everyone stand up, right? That's kind of how it works right there, okay? And if I didn't have that, it would be like, you know, when someone asks, like, tells you to do something, but kind of has a question sound in their voice, and you're confused by what they're telling you to do, like, stand up? All of you would go, is that a command, or are you asking us a question? We don't know, right? The semicolon alleviates that problem for the computer. It contains the thought, it puts a nice simple period on it, and contains the command there. So, we've talked now about variables. Variables, of course, are containers, and they store values, okay? And values will usually be different types of data that you're working with, okay? Well, we have different data types that we're going to be storing, calling, fetching, manipulating in Deluge. So those 5 different types, the first type of data type that we'll be using is text, okay? Now, an example of text will be something like tigers here, which you notice is in quotes. There's a reason for that, because whenever you're using text as a value, we always need to put it in quotes, okay? And this is something that in Deluge speak, we call a string, all right? So text is always going to be a string. And what this means is that we can't add or multiply or divide a string, right? Like we couldn't say, please find me the solution of, you know, the divided by or, right? That just does not make any sense. So this is a string, and it's going to be text, all right? Number 2 is we have numbers. And of course, in Deluge, we call this an integer, which, you know, remember our math classes and stuff like that, that term shouldn't feel too foreign to us. Now, what's of course nice about numbers as a data type is that we can treat them like numbers. We can add them, multiply, subtract, divide. We can do all sorts of different calculations with them, right? And that's why these two data types are different, and they're important to understand. Third data type is a decimal, right? So notice that integers, again, remembering our mathematics, are whole numbers here, okay? Decimals are treated a bit differently. So decimals, we call decimals. Thankfully, we didn't make some weird word for that, all right? Fourth is we have decisions, which are always going to be either true or false. And this is something in Deluge we call a Boolean. If you have some, math history behind you, you'd know that this is taken from Boolean algebra. And in fact, a lot of coding actually kind of works in a similar way to algebra, actually. It's kind of some of the basis for programming. So when we have a decision, we're either doing true or false. This is a Boolean data type. And fifth, we have date or date and time. In, Deluge, it's written like this, and we call it date and time, okay? So these are the 5 basic data types that we're going to be using. Every kind of piece of data that you might be collecting or storing will fall into one of these 5 categories. So we have variables, we have values, and we have all these different data types. Next, we have operators. Operators are going to be, the things that allow us to kind of start building the logic of the code that we're writing. So the first one are arithmetic operators, okay? And this is, signified here in our example by a plus sign, right? So without like arithmetic operators, we wouldn't really be able to write down like that we want to add something or subtract something or whatever. So far we know that we have variables, we have values, and that we have data types. So now we're kind of learning how we're going to be able to manipulate those things. And next we have, relational operators. As we can see here, 5 is greater than 3. This is, again, going to be something that's important because it allows us to go through, different relational things that help us produce, Boolean results of true or false and all sorts of things like that, which, again, will help us, especially when we're writing conditionals and other things. And then we have logical operators, which, again, add another level. So as we can see here, in our example, 5 is greater than 3, and 5 is less than 7. So these are logical operators. The logical operator is the and sign, which might be an and or an or something like that. It gives us a kind of logical way to, to measure or evaluate something. We'll go through these things now in a little bit more detail, and we're going to start with the arithmetic operators. These are the ones that we'll essentially be using in Deluge, where we have a plus sign, a minus sign, a asterisk that signifies multiplication, and a slash that is for division. These are all things that we might recognize on a calculator. They shouldn't be too foreign to us. So let's start playing with these things right now. Here's a simple problem. What is the value of A? Okay, so here we have another example that we can do. And again, this is an example that we're kind of doing in a vacuum for learning purposes, so don't get too caught up on the specifics. It's kind of the general concept that we're thinking about here, right? So what is this first name thing? What would we call that right here? The variable, right? And on the right side, Bruce is acting as a what right now? It's a value, and that value is a string. We have first name equals Bruce and last name equals Wayne. So if we say full name now, where we're declaring a new variable, which is full name equals first name plus last name, what is the answer we're going to get? What is going to get returned to us when we type in info full name? Bruce Wayne, no space, is what we're going to get. So just Bruce Wayne being run together. That the answer has no space in it. It's not actually making the assumption that we want to put a space in that, because even though we are saying first name, last name, the computer does not know that we're actually talking about a name, and it doesn't know that we usually put spaces between first names and last names. It just doesn't know that. So if we're going to want to add the space, we're going to need to tell the computer that, right? So this would be the proper way maybe to write this, right? Which is full name equals first name plus quotation space quotation plus last name, all right? So this is what's going to allow us to add the space. So the space is actually being treated right now as a string in of itself. The empty space, the non-character, is actually being used here. And this is what's going to give us Bruce Wayne. We have spaces in our code in general right now. So like we have a space in between the E and the equal sign and the F, and so forth. That is essentially just for our own clarity as being able to read this easier. You could run this all together like this, and essentially it would be fine. But this is just really for our own benefit. So I encourage you to make your code as readable and as legible as possible, okay? That was our arithmetic operators. Now we're going to move into the relational operators, all right? And these are going to kind of follow, the less than, greater than kind of signs. But we're also going to have a couple that we might not be as familiar with. So, for example, less than or equal to, the second one here is a, little guy like that, and then an equal sign. And, of course, we have greater than or equal to as well. We have the double equal sign. Again, this is, doubling up the sign, which may or may not be confusing to some of us. And then we have a exclamation point and equal sign, which is to say not equal to, okay? So does all this make fairly good sense? So let's go ahead and, think about this for a second, and then we'll do some examples. So when you're using relational operators, it's important to remember that the result is always either true or false. And that's the way that this needs to do. It actually always will give us an answer of either true or false. So this is the big takeaway when we're using relational operators, because it allows us to continue on, processing and manipulating data and so forth. So is 5 less than 3? False. Is 5 greater than 3? Okay. Is 5 equal to 3? Is 5 not equal to 3? So not too hard. That's the basics of this. If we can keep repeating that over and over and over again, we'll always be making good judgments and writing, good code. So something a little different. What's the answer to this? Remember, the computer is very literal. It takes everything into account there. So now this kind of segues nicely into logical operators. So when we see the double ampersand, we're saying that both conditions are true. And when we see the double straight line, it means at least one condition is true. It basically is giving us an or situation. So either this or that has to be true. Okay? So does anyone want to take a stab at this one? Okay, so let's break this down. We have 5 is not equal to 3, which is true. And we have 5 is less than 3, which is false. So what is the condition here that we are actually needing to fulfill? It's that they both need to be true, right? So with the and symbol, that's the two ands are basically saying that for this statement to be true or false, we're going to need them both to be true. So right now, the result, of course, is false. All right, so let's try it again. So we'll break it down again. We have 5 is not equal to 3, which is true, and 5 is less than 3, which is false. And since we're asking an either-or question right now with the double lines, we actually have true. So that's pretty much how those relational operators are going to work. And then when we add the logic to it, the logical operators, they just allow us to do things that are a little more complex and run different kinds of checks. Now, yesterday when we were making our peanut butter and jelly sandwiches, we had someone who was very clever and gave us an if statement, right? They said, if you can find the peanut butter or something, then pick it up and open it, right? So that was actually using a really good programming concept and a really important one, which are conditionals. And in Deluge, we have 3 different types of conditional statements that we can make, which are ifs, elses, and if-elses. So we're going to go ahead and see some examples for that real quick. So in if statement, we write like this. So if a condition is essentially happening, then we'll run another piece of code if the condition is true. And this is kind of the general way that this will get formatted. So in English, we can have a problem like, if it's earlier than 6 p.m., then say good day. Okay? That's how we might write this in English. And it's really important that when we're writing out logic or we're writing out a workflow, that if we're having a little trouble like trying to devise exactly what the logic is, we can use if-then statements to do this, okay? So if it's earlier than 6 p.m., then say good day. In Deluge, we would write it, if the hour is less than 18, alert good day. Now, why are we using 18 right there? International clock, right? 24-hour military time, whatever we want to say. So this is how we're going to get good day. So in this situation, 18 is standing in for 6 p.m., all right? So now we have else, right? This is another kind of condition. And what this allows us to do is add another kind of piece to the condition that we're creating. So for example, if condition, then run this block of code if the condition is true, else run this block of code if the condition is false. So this allows us to say, do this if it's true, do this if it's false. Do this if it's true, do that if it's false. That's probably a better way to say it. Let's continue our time analogy here, which of course would make sense because if we're going to write some script to, alert people or tell people good day, we might want to also have one that says good evening. So if the hour is less than 18, we'll alert good day. Else, meaning this condition is not true, we will then alert good evening, right? So it's either going to be one or the other. In this code, we're using 6 o'clock as the condition to say either good day or good evening, all right? And this is a pretty nice little thing. It's a pretty easy thing to do. So again, we can make this a little more complicated with our else if, okay? So for example, if condition 1, run this code if the condition is true. Else if condition 2, run this code if condition is false and condition 2 is true. Else execute if the conditional 1 and condition 2 are false, right? So that starts to become a little bit more of a mouthful, but it's a little easier to see if we just kind of write it out, right? So this is a different way of doing this. So if we say if now the hour is less than 10, we'll alert good morning. Else if the hour is less than 18, we'll say good day. And else anything else, we'll say good evening, all right? So good morning. If not 10, or if it's after 10, we'll say good day. If it's still earlier than 6 or 18, and that gives us then good evening for all the other cases, all right? I know, it's one of those things that as we kind of like explain it and talk about it and have to write it out in different ways, it kind of almost feels like it gets more confusing. But if we actually look at these things, it's not too hard to kind of figure out. In some ways, the code actually becomes easier to understand than the definition or the explanation of the code itself, right? Because that means that this is code that we can actually learn to read, right? It's like, have you ever been asked, like, you use a word and someone goes, hey, what's that word mean? And you're like, I know what it means, but it's very hard for me to find all the other words to define exactly what I mean, right? So, similar way, right? So there's a few other things we can do is we can use Deluge with forms. And this is, again, just a few more basic things. Like variables, we can actually assign values to fields. So, fields and variables can kind of be used in similar ways. And the syntax that you can use for that is input dot and then use the field Deluge name, and then you can assign a value to it. So you could auto-populate fields with certain data if you wanted to. And you can write this, essentially the syntax has an alternate way of doing it, which you don't have to use the word input. But the problem with this then is that your field Deluge names, the fields you're referencing and the variables you're creating can get it's hard to remember the difference between them. So generally speaking, we recommend when you're doing scripting and you're using fields that you're loading Deluge into or whatever, to use input, because it's going to just help you differentiate those two things, all right? And lastly, you'll be able to hide and show fields, which allows you to just actually manipulate the field itself rather than the values within it. All right, thank you very much. I appreciate it.